We're team 19033, and our project was to create a custom Python API generator, which we've called Facil. The problem that our project addresses is that a lot of software meant to be used by humans through a graphical user interface lack an application programming interface, or an API. Basically, an API allows an application to be controlled or used by other software. It's often desirable to automate tasks in an application with one's own custom software, but this is generally not possible if the application lacks an API. And so Facil is a tool that generates Python APIs for an application, enabling a user to automate the application with their own Python scripts.
Now we'll talk about our ConOps and system requirements. The user can generate a Facil API in 3 simple steps. The API can then be used in a custom program. A Facil API is a specialized Python package, which makes Facil a code generator. The structure of a Facil API is complicated, but the user doesn't have to understand the files to use the API. The script that uses the API can be just a few lines long. Each API comes with complete documentation for the user to refer to. This is an example of generated HTML documentation. 3 other forms can be generated as well. To generate a Facil API, the user must build 2 models. These models describe the structure of the target GUI and the actions to be performed on the target GUI. The key system requirements are: Facil shall have a graphical user interface, it shall use a custom library to communicate with the target GUI, it shall generate Python packages, and it shall generate documentation for the Python packages. Here are our subsystem requirements, and here are our subassembly requirements.
Now we're going to talk about our delivered product in terms of our system block diagram. Alright, so here's our system block diagram, which shows Facil in its delivered state. Let's break it down and talk a bit about how we prioritized Facil's development using the Agile philosophy. The goal of the first phase of development was to have a minimum viable product which would allow the user to model the target GUI. This involved creating a basic version of Facil's GUI, defining the internal data structures making up the target GUI model, creating the mechanisms which allow Facil to save and load projects, and creating our target GUI interface library, which provides the mechanisms Facil uses to detect components of the target GUI. The goal of phase 2 was to create the functionality that would allow a user to produce an API. This involved completing the remaining features of Facil's GUI, defining the API model data structures, creating the API compiler, and defining the form that the generated APIs take. The third phase of development was devoted to polishing and debugging everything.
Now we'll talk about design and verification. Our verification process shows the order in which to perform our tests. Each requirement has an associated acceptance test procedure and data sheet in the verification document. You can clearly see which requirements were verified at each iteration. CDR and ISR were primarily focused on functionality within Facil, and FAR was primarily focused on functionality of generated APIs and performance. This diagram shows how requirements were verified throughout the Agile development lifecycle. A set of requirements were either fully or partially verified at each given iteration. This table is a simplified version of a trade study we conducted, which compares existing automation solutions to Facil. The automation solutions being compared are handwritten code, recording mouse and keyboard events, then playing them back in the form of macros, Leapwork, which is a similar program to Facil, and then Facil itself. Facil provides flexible automation by generating code that can be used by another program. Because of this, some coding is required, which can be seen as Facil's biggest drawback. Facil makes it easy to quickly produce documented automation solutions, and because Facil uses a project-based structure to create APIs, the APIs are easily maintainable by simply opening the project, editing the models, and then recompiling the API. Multiple Facil APIs can be created and used within a user-written program to provide cross-application automation. Our Design Day poster gives an overview of Facil and presents our findings. Feel free to pause the video and read if you'd like. We're prioritizing our time for the demo because it shows our system more thoroughly. We'll now discuss delivery performance briefly, and then give a demonstration of our system. Most of our requirements had binary pass or fail criteria, but 5 requirements were measurable. These requirements comfortably pass with wide margins. All system requirements were met. All subsystem requirements were met as well, and all subassembly requirements were met. In this video, we'll be creating a simple API to control the Notepad application on Windows. First, we start the application and then explore it using the observer. This is mostly done automatically, as you can see, as you interact with the target GUI. Once the user has sufficiently explored the target GUI, they can use visibility behaviors to describe relationships between components. The user can then describe functions they would like to perform in the target GUI using action pipelines. Action pipelines contain actions that are linked to components, and wires are used to describe the data flow between these actions. Each action may have a set of inputs and outputs, exactly like a function. Actions are translated into functions in the generated API. Facil detects errors in your models and won't let you compile until you fix them. This ensures that your API behaves properly. You can generate 4 different formats of documentation and select to install the API automatically. The documentation contains custom annotations from the models in the project. The user can set these. You can use the API with just a few lines of simple code. Now you can sit back and watch your program do the work for you.
Here are some lessons we learned. Separating the software design into small independent parts causes less confusion and makes it easier to maintain. Customer feedback during each iteration helped adapt the software development more towards the needs of the end user, which increased the usability of the software. We planned a little too much to do for a lot of the agile sprints. Technical debt accumulated, but we learned our limits as we progressed through our project. Our system requirements could have been organized a little more logically and intuitively, we felt like. And we could have done more partial testing for certain requirements during development instead of waiting till the final iteration to carry out the testing. Overall, the project really helped us grasp modern-day practices of agile methodology. Here's a listing of all our project deliverables, past, present, and future. As you can see towards the bottom highlighted, we'll be delivering Facil's source code, executable installer, and documentation package. Essentially, Facade Technologies, our sponsor, is receiving a fully working product along with the documentation they would need to continue building off it. On behalf of Team 19033, thanks for watching.